I'm going to talk about integration with respect to horizontal rectangles. By horizontal rectangles and vertical rectangles, I'm referring to the direction of the longest side of rectangles. Okay? Now, I'll assume that you know the basics of integration, including how to use integration to find regions between the graphs of two functions. All right? If you're unclear about any of the basics of integration, I would invite you to watch my videos on the basics of integration, whatever topic you need help with. All right? Now, I'd like to do an example using horizontal rectangles. So give me a minute to make a picture. Okay, so I've drawn a portion of the graph of the x squared function. I've also drawn a portion of the graph of the function equal to 4. Now, I'd like to discuss how to find the area of the yellow region. Okay? Now, we could find the area with integration using vertical or horizontal rectangles. Okay? Let me draw a few horizontal rectangles in the yellow region. Okay? So, can you see that every different horizontal rectangle in the yellow region is going to be with respect to a different y value? Can you also see that the length, the longest dimension of the horizontal rectangle is going to be with respect to an x value? All right. So for those regions, we're going to want to use the inverse of the x squared function to calculate the area using integration with respect to horizontal rectangles. So in other words, instead of using the function y equal to x squared, we're going to use the function x equal to the square root of y. Okay? And instead of integrating with respect to x from 0 to 2, we're going to integrate with respect to y from 0 to 4. That's going to add up the areas of all the horizontal rectangles that we need to add up. Okay? So the integral will look like this. The integral from 0 to 4 of the square root of y with respect to y. So let's go ahead and find what that's equal to. So doing that integral, we get y to the 3/2 divided by 3/2 evaluated with respect to 4 and 0. So that gives 4 to the 3/2 divided by 3/2 minus 0, which gives, let's see, 4 is 2 squared to the 3/2 power, that's 8. 2/3 of 8 That's equal to 16 thirds. Okay? Now, let me repeat that to do an integral with respect to horizontal rectangles, you're going to do the integral with respect to y, okay? And your limits of integration are going to be with respect to y values. Now, I would invite you to find the area of the same region using vertical rectangles and convince yourself that you will get the same answer. Okay? In other words, you would find the integral from 0 to 2 of 4 minus x squared with respect to x. Okay? Do that and you'll see that you will get 16 thirds. Okay? Let's continue. So, you might wonder, why would you ever want to do an integral with respect to horizontal rectangles? Well, it'll turn out that sometimes it's easier to find the area of a region with respect to horizontal rectangles. Okay? Let me show you a picture where that might be the case. So give me a minute to make another drawing. Suppose you wanted to find the area of the yellow region, okay? And can you see that if you found that area using vertical rectangles, can you see that you would have to break up the area into two pieces? Okay, so for a part of that yellow region, you could find the height of the vertical rectangles by finding simply the y value with respect to that purple line segment. Okay, but once you got to rectangles that were resting on the blue curve, you would have to, of course, incorporate that into the integration, so that would force you to use two integrals. However, if you did the integration with respect to horizontal rectangles, you wouldn't have to split it up. Okay? All the red horizontal rectangles can be, their longest dimension can be described as the distance from the y-axis to the corresponding point on the blue curve. Okay? So there's one example to convince you that horizontal rectangles might be a useful way to do integration. All right? Now, let's have you do an example. Let me, as before, have a minute to make a picture first. All right, I'd like you to find the area of the yellow region. All right, the yellow region is defined with respect to the graph of the x squared function, which I've drawn in the picture, as well as the line through the points with coordinates 0, 2 and 2, 0. And below, from below, the yellow region is defined with respect to the x-axis. Okay, and I'd like you to find the area two ways, using integration with respect to horizontal rectangles as well as vertical rectangles. So pause the video and work that out now, please. Okay, so I'll go ahead and work it out myself now. So first we need to determine a few things. Let's determine the point of intersection. So to do that, we're going to need to determine the function that corresponds to the purple line. So that line has a y-intercept of 2 and a slope of -1, so 2 minus x. And so the intercept, if you work it out, you'll see that it's the point with coordinates 1, 1. Okay, so now using vertical rectangles, we'll have to do two integrals. The integral from 0 to 1 of x squared dx, and then we have to integrate from 1 to 2 the integral of 2 minus x. Okay, and so that will give x cubed over 3 evaluated with respect to 1 and 0 plus 2x minus x squared over 2 evaluated with respect to 2 and 1. So the first difference that we need to evaluate is 1/3 minus 0. The other difference is 4 minus 4 over 2 minus 2 minus 1/2. You can get that by plugging in the 2 and the 1 and evaluating the expression. So that gives 1/3 plus, and then let's see, 4 minus 4/2 is 2, minus 2 plus 1/2. So we have 1/3 plus 1/2, which is equal to 3/6 and 2/6, so 5/6. Okay, now let's evaluate it using horizontal rectangles. So let's find the corresponding inverse functions. So we will use, for the blue curve, we will use the square root of y. For the purple line, we will use 2 minus y. So that is an interesting, 2 minus x is an interesting function because the inverse function and the original function are the same function if you replace x with y, you get the inverse function. All right, so for that integral, we're going to do the integral from 0 to 1 of 2 minus y minus the square root of y with respect to y. Okay, and we only have to do one integral, which is kind of nice with respect to horizontal rectangles. So 2y minus y squared over 2 minus y to the 3/2 divided by 3/2, and we'll evaluate that at 1 and 0. So evaluating it at 0 will just give 0, so we'll end up with just what we get when we evaluate it with respect to 1. So 2 minus 1/2 minus, and then the last piece, 2/3, and I think that's it. So that's 3/2 minus 2/3, or let's see, what is that? What's that equivalent to? Times 9, 9 6 minus 4 6 is 5 6. All right, and so we got the same answer both ways, which of course is a good sign, and I hope that is what you got.